Now let's go to problem 2. The Associated Press reported that in a survey of 4,722 American youngsters aged 6 to 19, 15% were seriously overweight. What do you mean by serious overweight? A body mass index at least 30. Based on this study, find a 98% confidence interval for the true proportion of American youngsters who are seriously overweight. Provide the justifications to all your steps, and so on and so forth. Okay, how do we handle this problem? First, we have to make decision. Is it going to be T-curve problem or is it going to be a Z-curve problem? T or Z? It's going to be Z-curve. Why? We have really large sample size, 4,000 something, usually 100 or bigger, then I like to use Z-curve. So it's going to be a Z-curve problem. Maybe that should be step 0 of this problem. Okay, maybe I'll insert that step. Step 0. T or T table or Z table. N is given as 4,722, and that's really large. Therefore, we'll use T-curve and T-table. Okay, that is step 0 of the problem. Okay, we made decision. Alright, let's go to the initial picture. Oh, what did I write? Excuse me. Large sample size, so it's Z-curve. Sorry for confusion. Large sample size, so we use the central limit theorem. So it's the Z-curve. Alright, here is the initial picture. Outline, center, end, and then shade. And then what is the center here? The problem said 15% was seriously overweight. That goes in the middle. And then, okay, alright. Here we go. 15%. And we want 98% in the middle. And x1, x2, 1% to the left, 1% to the right, blue and red respectively. And we are looking for these endpoints, x1 and x2. One more thing, this is about binomial. So we use the SE formula given as follows. SE is square root of p times 1 minus p over n. In this case, 0.15 is observed proportion. 1 minus of that over n value 4,722. I did the computation with Mathematica. I ended up with 0.0052 approximately, but I'm going to use as many decimal digits as possible in the intermediate step so that I can round only at the very last moment. So I'm going to use this entire digit string later on. So that's the SE formula. Here's the initial picture. And then we're going to use the Z-curve. Now, before just giving away the answer, let's work out a little bit more. So Z-score is end minus center over SC, isn't it? And we are looking for this blue X value minus 0.15. 15% stereo decimal is 0.15. And then we are using this standard error. We calculate it. And this whole thing is going to be approximately equal to appropriate Z-score associated 98% here, 1% there, and 1% there. What is that Z-score? We can find out through our Z-table. Okay, here's the Z-table, standard normal table. And we are looking for 1% in the left-hand side. So let's look for 1%. this I think is the closest, 0.0099. So negative 2.33 is gonna be my z-score associated to this left hand side. So negative 2.33. Solving this equation, you can get x. Using the symmetry, you can find x2. Exactly the same thing as what we had been doing in the previous chapter, chapter 8, except that the denominator requires another formula right here. Square root of p, 1 minus p over n. Here is the full solution. That's SE formula, and here's a little bit more accurate z-score using technology. With z-table I get negative 2.33. I use Mathematica, so I got a whole lot more decimal digits to get a little bit more accurate value. Flip over the denominator and then flip over the mean and then calculate. I get 0.13 something, and then use symmetry, change this to plus and run the calculation. I get 0.16 something, and that leads to this conclusion. 98% confidence interval is, oh wait a minute, there's a typo. 0.138, not 148, sorry about that, and 0.162. So 13.8% to 16.2% if you prefer percentages. And that is the 98% confidence interval for true proportion of American youngsters who are seriously overweight. Okay, do we have time to go over to the next problem without wait? Not really, so let me stop the recording and let's resume problem 3 in a separate video.